Chapter 8, Explanations, Fakie 2. I'm not going to go very slowly because you can always hit pause and rewind. Please bring in a written set of questions if you're still confused. Number 1, we want to know the angle the wheel rotated in radians. Distance equals theta, that's angle, times radius. Solving for angle, because what angle did, that's our question. Distance over radius is what we need. We know the distance on the outside of the wheel. We know the radius of the wheel. When I divide the distance of the outside by the radius, what I get is sort of radiuses. How many radiuses worth did it rotate through? And that's called radians, just with rad. So we just divide this. The meters actually cancel out. And what we get is sort of a non-unit called radians. I like to write it down because I start to forget what I don't have, or what I do have. But if you say, for instance, you multiplied radians times meters, you would not get radian meters, you would just get meters. 2. The tire has a radius of 55 centimeters and is turning at 700 centimeters per second on the outside edge. What's the angular velocity in radians per second? When I divide by the radius, what I get is radians. And in this case, it's going to be meters per second, so I'm going to get radians per second. I don't need to convert this to meters because centimeters over centimeters is going to cancel out. And it's going to give me radians per second. This, of course, is solving for omega here, the sort of fat W. The R goes through, changes levels, and ends up on the bottom. Number 3, a steering wheel is rotated 180 degrees. It has a radius of 25 centimeters. And how far did the outer edge actually rotate? Well, how many rotations was that? 180 degrees. How many rotations? Well, since a full rotation is 360 degrees, 180 divided by 360 is half a revolution, isn't it? And in radians, that's going to convert like this. There are 2 pi radians per every revolution. So this is going to cancel out revolutions. Multiply by 2 times pi, and you're going to get 3.14 radians. That's how far it went in the angle. But what's the actual question? How far did the outer edge actually rotate? So now we know the angle. We know theta. Back to number 1, for instance. Distance equals theta times r. And in this case, I don't need to rearrange because all I want is the distance. Distance equals 3.14 radians. That's theta. Times 25 centimeters. That's radius. And you get 78.5 centimeters. You could convert this to meters, and then your answer would be in meters, but the question didn't specify, so if you want to keep it in centimeters, that should be fine. A propeller spins at 7,000 revolutions per minute. What is the angular velocity in radians per second? This is just really a conversion problem because we already know its angular velocity. We know its distance over time, and that's what angular velocity is. It's distance rotating over time, but it's really just a conversion to radians per second. You can do this in any order. I decided to do 2 pi radians per revolution first. That cancels out the revolutions. And then the minutes on here needs to be on top so that minutes will cancel out. And it's 1 minute for every 60 seconds. This is multiply, 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 divide by 60, and you should get 733 radians per second. What is the propeller's angular displacement in 6 seconds of time? Now, displacement meaning distance, the angular distance. Well, the distance measured as the angle in radians. So we know that from number 4, it went 733 radians per second. Now, it's doing that much rotating per second. So if I multiply by 6 seconds, I'll get how many total radians it went through. And so the seconds are going to cancel out. It's just going to be 733 times 6. You should get this. Number 6, a propeller slows down from 4,000 revolutions to 1,000 revolutions per minute in 4 seconds. What's the angular acceleration? Now, what we're going to need to do is do a lot of converting, really. And I know it's decelerating, so I want to get a negative answer. So I deliberately subtracted here the difference. How much did it change? It changed between 1,000 revolutions per minute and 4,000. And I want to set this up so I get a negative number because I know it's slowing down. I want my answer in the angular acceleration to be negative because that's slowing down. So I know the change is negative 3,000 revolutions per minute. I'm going to convert this to radians per second because it says in radians per second here. 2 pi radians for every 1 revolution. This cancels out revolutions. Top, bottom cancels out. 1 minute per 60 seconds. The minutes will cancel out. It's this times 2 times pi divided by 60. You should get negative 314 radians per second. Now, that's the angular velocity at the moment, okay? That was the angular change in general, but how long did it take to do it? Did it take it a minute, a day, or 4 seconds? It did it in 4 seconds. And besides, I know that acceleration has the time squared on the bottom, time squared, and this is not time squared. So what we're going to do here is divide by the 4 seconds, 3.14 divided by 4 seconds. The seconds are actually going to now be squared on the bottom here. We get negative 78.5 radians per second squared, which is the unit that was requested.